How do you determine domain when it's not obvious? Imagine trying to find out which numbers you can plug into a function without causing any problems. Sometimes it's clear, like with simple lines, but other times it's tricky. That's when you need to do a little detective work. First, think about what kind of function you're dealing with. If it has fractions, watch out for values that make the denominator 0 because dividing by 0 is not allowed. For example, if you see a function like 1 divided by x minus 2, you know you cannot have equal to 2 because that would make the bottom 0. Next, look for square roots or other even roots. The thing inside the root must be 0 or positive because you can't take the square root of a negative number in real numbers. If you see a square root like square root of x minus 4, set the inside greater than or equal to 0. That gives you x minus for greater than or equal to 0, which means has to be at least 4. So, the domain includes all numbers from 4 to infinity. Now, sometimes the function isn't so straightforward. You might have to solve inequalities to find the valid x values. For example, if the function involves a quadratic expression or a more complex algebraic expression, you'll need to find where it's defined. This often involves solving inequalities like x squared minus 5x greater than or equal to 0. Once you find the solution set, that's your domain. If the function is a simple line, like y equals 2 times x plus 3, then the domain is all real numbers because there are no restrictions. But if it's a rational function or involves roots, you need to check for restrictions. For rational functions, exclude any x values that make the denominator 0. For radical functions, make sure the expression inside the root is not negative. You can also use interval notation to write down the domain. For example, if x must be greater than or equal to 4, you write it as 4 infinity. If there are no restrictions at all, the domain is all real numbers, which you write as negative infinity to positive infinity. Graphing the function can help you see where it exists and where it doesn't. If you plot the graph and notice parts where the function is missing or undefined, that's a sign of restrictions. This visual check can confirm your calculations. In linear functions, the domain is usually all real numbers because lines extend infinitely in both directions. But when you see roots or fractions, you need to check for restrictions carefully. By examining the function's formula and solving the related equations or inequalities, you can find the domain even when it's not obvious. This way, you'll know exactly which x values work and which don't, making your understanding of functions much clearer.